So which means, can we hear me please?
Yes.
Okay. Which means when you want to name this compound, you call it tetraoxo sulfate. That sulfate is what you just calculated for. Is already 6. So you put that in Roman numeral, and you put your aeon there. Aeon in the sense that it is having this charge, okay? So that's tetraoxo 6 aeon. So how about a case of water? In water as well, it is expected of you that when we sum up, summation of oxidation number here will be equals to what? Anybody? Can anybody try? The summation of oxidation number here will be equals to what value?
So
Exactly. So it simply means you are having two hydrogen atoms plus one oxygen atom. Everything should be equals to 0. Okay? Which of course when you prove it, hydrogen is plus 1, your oxygen is minus 2. So you have 2 minus 2, which is equal to 0. Alright, so those are just the rules of oxidation number. So we use this concept of oxidation number to predict the compound that will be formed between two atoms. Okay? So for example, in the question we are about to solve for, this is the question 62. There the question says CaC2, that's calcium carbide. Now imagine that you never knew the chemical formula for calcium carbide before. This calcium, a combination of calcium and carbon. It's a combination of calcium and carbon. Whenever carbon combines with any other atoms, it becomes carbide. Okay? Especially when it's combined with metals. As calcium here belongs to the metal group 2 elements, which are alkali earth metals. We're still going to talk about that when we get to the periodic table. So when the two of them combine together, we kind of have the, what's it called now? The chemical formula to be CaC2, meaning that you are having two of this carbon, combining with one of calcium. Why is it like that? Calcium is Ca2 plus. Do we all agree with me that calcium is Ca2 plus? Do we all agree? Okay.
Yes, sir.
Okay.
sure.
Meaning that when you draw the structure, you have, I'm going to be assuming that you are having, of course, you already have some background knowledge of this chemistry concept. So when you draw the structure, you're going to normal calcium. Calcium is of atomic number 20. So you go to 20. That's one. You have two there. You have three. You have four, 5, 6, 7, 8, 9, 10. We are arranging the atoms. 11, 12, 13, 14, 15, 16, 17, 18, and then, oh sorry, and then I need to add one more, right? 18, 19, and then 20. However, carbon carbon is just and what's it called now? Carbon is of atomic number 6. That means the smallest shell will take 2 and the rest will be 4. 1, 2, and then 3, 4, 5, 6. When you look at it, even if calcium is going to donate these 2 down to this one, this carbon here will still not be complete. Are we still together?
Yes, sir.
Okay. So even though this one is calcium, it is going to donate these 2 valence electrons to this one, it will be complete, because this one is needing how many valence electrons to be completed? It's needing 4. That is, 1 to be here, 1 to be there, 1 to be here as well, and 1 to be on this other side. So kind of nature has provided that 2 of carbons need to come together, and then they now need to combine with this, what's it called, with this calcium. So that is why you have the what's it called, the molecular formula being CaC2. Let me see, if this one and this one combined with this one, how is the structure then going to look like? We have one there, how should I put that now? Okay, let me just point the fact that it will be a sharing of electrons. Sharing of electrons is important. It is not a donation of electrons. So I don't want to spend too much on that, as I'm already staying too long there. So very very quickly. So the question is now saying that okay, this calcium carbide is combining with water. So whenever you have a reaction like this, you must first try to denote what kind of product are you likely to form. So when you work with chemical equations very well, you'll likely be much better in writing a very balanced chemical equation. So yes, this is one kind of chemical reaction in organic chemistry. A kind of reaction of a cold water or calcium carbide. We are going to form a calcium hydroxide, and then as well ethyne will be formed, C2H2. To balance it up, we put 2 here. So that is the equation you have there in that thing. Now you see this calcium carbide is a solid. Your water, I said a cold water, so it's definitely in liquid. So as a matter of fact, if that should happen, calcium hydroxide, that's a kind of what's it called now, a slicked line. You're also going to have that to be liquid. However, this one here, ethyne is a gas. Okay, can we still all this hear me?
Yes.
Okay, very good. So the question says, yes, you have that. What is the mass of the solid? That is, you want to look for the mass of the solid calcium carbide needed to produce 5.6 dm cube of ethyne. You can see that 5.6 dm cube of ethyne at what? STP, standard temperature and pressure. So the volume of this guy produced is 5.6 dm cube. So remember, from a balanced chemical equation, you can simply predict how the reaction, or in what direction the reaction is going to. Here, this shows that 1 mole of calcium carbide is reacting with 2 moles of this cold water to form 1 mole of this slaked lime, that's calcium hydroxide, and 1 mole of ethyne, that is the gas there. However, the question asks you for the mass of this solid that will be required to produce 5.6 dm cube of ethyne. So which means that one thing beautiful about chemistry is you can just simply relate them together. We call it mole to mole relationship. You relate the mole of this, the one you're looking for. Oh, okay, no problem.
Yes, sir.
Alright, so you want to do mole to mole relationship. Since you're giving a value for this one, that is 5.6 dm, you find a way of converting this one, that is this 5.6 dm, to mole, and then you now relate it back to this one. Now let's calculate the mole of this ethyne that is being produced. So remember, whenever you're dealing with gas, remember it said that the question says at STP. Whenever it's mentioned at STP to you, it implies that the molar gas volume is involved. The molar gas volume is involved, and what is the value? The value is 22.4 dm. So what would you do then? Whenever you're dealing with volumes like that, dm per mole is there. Whenever you have something like that, something involving volume, you say your mole will be equal to the volume of the gas divided by the molar gas volume. Okay, so volume of gas, of course, 5.6 dm cube is produced. 5.6 dm cube is produced divided by molar gas volume 22.4 dm cube per mole. You must ensure that your units are tallying together. They are tallying. You must ensure that they are tallying. So dm cube cancel out dm cube, mole per mole comes up to become a mole. Someone help me to calculate this value. 5.6 divided by 22.4, please. What do we get?